Here now once again the second important use of the total internal reflection phenomena is done by an optical fiber. And my dear, this is a two question, the total reflecting prism, the earlier video, and the optical fiber is very important question as compared to sparkling of diamond and my dear, the one more, if you remember, the sparkling of diamond is one and the other is mirage formation. So my dear, the other two topics are not so important. There is some general information is required in mirage formation and in sparkling or brilliancy of diamond. But my dear, these two topics, the total reflecting prism and optical fiber, are very important as the CBSE board point of view. So in question for optical fiber is, what are optical fiber? That is the first question. Here I have drawn the diagram. This is the complete diagram. Here the optical fiber has a two very important component, you can say, two very important body of which the optical fiber is composed of, and they are core. I have written C-O-R-E, core, and cladding. Please take care, core and cladding. So whenever we study optical fiber, a student should aware about these two words, core and cladding. And my dear, looking to this, if you can see the diagram carefully, core is covered by cladding. Matlab, it is something like this. For example, my dear, this is my hand and this is the marker pen which you are seeing. Now this, if I hold like this, so the outer edge, this end, the edge you are seeing, this one is cladding, and this one, the marker, is act as a core. The structure is like this. The structure is like this. This is acting as a cladding. This thing is acting as a cladding, and this marker you can see is act as a core. Right now. So core and cladding together form a optical fiber. They are very important part of the optical fiber. They are only the compositions of optical fiber, that is core and cladding. And I have shown like this. So who is inside? Core is inside and cladding is covering the core. Am I clear? And further, the core and cladding both will cover. Core and cladding both will be covered for extra safety, my dear. This core and cladding both will be covered by a plastic jacket. Both will be enclosed in one of the plastic jacket, right? Am I clear? And that is called buffer coating. By why we are doing this buffer coating? For extra strength to provide an optical fiber, or for safety of an optical fiber, we are enclosing this core and cladding, or you can say we are putting this core and cladding inside a plastic jacket. Am I clear? So this is giving an extra support to the core and cladding of an optical fiber. So my dear, the question is, what are optical fiber? On which principle do they work? How does light propagate through optical fiber? How does the light propagate through optical fiber? I have shown in this diagram. I have written here propagation of light through optical fiber. This is the diagram which shows. And my dear, you can see, while propagation of light through optical fiber, a very important term is coming. There is a multiple total internal reflection taking place. Multiple number of total internal reflection taking place from one side, from incident side to emerging side. You can see. And the optical signal get transmitted from one end to the other end without any loss of intensity. This is what happening in telephone conversations, my dear. You are talking from that side, the other side I am listening to this side, but there is no loss of intensity. You will observe, my dear, this is what is a fantastic. Today entire telecommunication is based on optical fiber. And therefore this is very important question with the current affairs. And last question is, what is light pipe? Oh God. What is light pipe? My dear, it is a bundle of fibers. It is a bundle of optical fibers. Bundle. Am I clear? Here I have drawn one fiber, but there will be a bundle of fibers when together is called light pipe, and this is used in medical purposes, so called as endoscopy. There is a lot of use of light pipe, my dear. Am I clear? So what is light pipe? We will discuss. And last, what is an applications of optical fiber? So let's begin with the optical fiber. I have drawn the two diagram. One diagram is the structure showing optical fiber. Another diagram is how the light entered to the one end of the fiber and it will be emerging out from the other end with what condition, that is a condition of total internal refraction, you can see. So my dear, let's start with the topic here with the optical fiber. So now let's begin with the first part. What are optical fiber? The first question is optical fiber. What are optical fibers? So my dear, here I have drawn. So I will start with the core. Explanation of core, then followed by cladding, and then followed by buffer coating. As soon as I'll complete this explanation, say optical fiber is over. Am I clear? What are optical fiber is over? So here is the answer, my dear. Optical fiber is a device, you can say, is a device consists of, is a device, am I clear, which consists of thin, or you can say hair thin. Hair thin. You can see how the hair is thin. So this core is like that. This core I am talking about is hair thin long strand. So my dear, optical fiber is a device consists of hair thin long. See, try to understand. Hair thin long strand. Am I clear? It consists of hair thin long strand made up of high quality, wow, not a normal quality, cheap quality. So optical fiber is a device, sir, consists of hair thin. I am talking about core. I am just giving the description of core from here. Consists of hair thin long strand, I said strand, made up of high quality glass, silica or quartz. It's made up of high quality glass or high quality silica or high quality quartz of refractive index mu1. I have taken the refractive index mu1 called core of optical fiber. इसको ऑप्टिकल फाइबर का कोर बोलते हैं. क्या बोलते हैं? कोर. And my dear, I will tell you the refractive index of typical optical fiber for core. For here, please make a note of this. Note, for typical optical fiber, the refractive index Ri of core, that is mu1, is 1.52. Please take care of this. So this is, I have description about core, my dear. But still the optical fiber is keep on going. So here, my dear, I said optical fiber is a device which consists of hair thin long strand. Hair, like hair thin. Long also, you can see long hair. This is I am talking about. Hair thin long strand made up of, hair thin long strand made up of, here I am putting comma, made up of high quality either glass, high quality either silica or high quality quartz. Please take care. Core is made up of either glass, silica or quartz. Am I clear? Of refractive index I have taken as mu1 in the figure. So of refractive index mu1 called core of optical fiber. This part is called core of optical fiber, and for I have made that note. For typical optical fiber, my dear, the Ri of core is 1.52. Because this is all required in MCQ, don't leave the topic. Okay. Now, my dear, this is the further, I will continue. So here I am writing in note, so I will put box. So core of optical fiber. Further, the core of fiber is covered or is surrounded. You can see this core is surrounded. I told you na, this marker is surrounded. So the marker is core and this is surrounded. So this is surrounded by what? To whom? That is called what? Cladding. So the core of fiber is surrounded by what? My dear, this is also made up of something. Am I clear? This is also made up of something. So I am writing by cladding made up of glass or plastic. Made up of glass or plastic. Am I clear? This cladding is either made up of glass or plastic of refractive index Ri mu 2 of Ri mu 2 such that mu 1 is greater than mu 2. That is, Ri of core is more than Ri of cladding. And I am writing here again note, for typical fiber, for typical optical fiber, my dear, the Ri of cladding that is mu 2 is equal to 1.48. This is the note point, and you can see from this 2 point, 1.52 is greater than 1.48, and that's what I have written. The cladding is made up of glass or plastic of Ri mu 2, because Ri is always for material, so it is made up of glass or plastic of Ri mu 2 such that mu 1 is greater than mu 2. That is, Ri of core is more than Ri of cladding. And for typical fibers, our Ri of core is 1.52 and Ri of cladding is 1.48. I hope it is clear. And now, my dear, to provide, I will continue this. So this is first statement, this is second statement, and this is third statement. To provide safety and strength, the core and cladding, to provide safety and strength, the core and cladding of optical fiber, the core and cladding of optical fiber is surrounded by, or is surrounded, is, I'm repeating barbar, so is enclosed. To provide safety and strength, the core and cladding of optical fiber is enclosed in plastic jacket called buffer coating. Coating ka matlab, you all know that what is coating. So this is called buffer coating. So my dear, why buffer coating is done? Sir, buffer coating is done to provide extra safety, extra strength to the fiber. And how we are doing this? Sir, to provide safety and strength, the core and cladding of the fiber, this both will be further enclosed in a plastic, enclosed in a plastic jacket called buffer coating. This process called buffer coating. I hope, my dear, so this is what about is an optical fiber. So I want my student should know this much entirely for fiber. If anybody will ask you, you should answer this properly, that sir, optical fiber is a device which is made up of a hair thin long strand. It consists of hair thin long strand, because I am talking about core first. So this part is about core, this part is about cladding. So here the core of fiber is surrounded by cladding, and the third part is about buffer coating. So these are the three parts which you are supposed to know. So my dear, as soon as I start, the fiber is a device consists of hair thin long strand, which is made up of this hair thin long strand is made up of high quality either glass, either silica or quartz, which has a refractive index of mu1, and that for typical fiber, my dear, we call this entire thing as a core. And my dear, this for typical fiber, this core refractive index is 1.5. Similarly, the core of fiber is further surrounded by a cladding. You can see this cladding is made up of glass or plastic of refractive index mu2. I said mu2, such that the core Ri is more than cladding Ri. Mu1 is greater than mu2. Am I clear? And I have mentioned that also for typical fiber, the cladding Ri is 1.48 and core Ri is 1.52. So, but natural, the core has a higher Ri than cladding. And the last, my dear, this both core and cladding is enclosed in a plastic jacket. Core and cladding is enclosed in a plastic jacket. Why we have done this? Why we have enclosed further this in plastic jacket? So that it provide extra safety and strength to the fiber, and this process is called buffer coating. So I hope this is all clear about what are optical fiber. Now let's go on which principle do they work? The next question is on which principle do they work? So very easy answer. Point number 4. They work on the principle of total internal reflection. Simple. So they work on the principle of total internal reflection. So my dear, I hope the first two part of the question is over, that what are optical fiber and on which principle do they work. So let's start for how does the light propagate. That is this diagram. Now we will discuss that how does the light or any optical signal, light signal or optical signal will pass through the optical fiber. This is my next question to discuss. So now my dear, we will discuss that how does the light propagate through the optical fiber. And here is the diagram for propagation of light through optical fiber. You can see in the figure that from this end, from one end of the fiber, the light entered, the incident ray entered at certain angle, right? It passed inside here. You can see here, my dear, the ray fall at this point, my dear, it suffer total internal reflection. Again at this point it suffered total internal reflection, it went here. Again here it suffered total internal reflection, it came here. Here it suffered total internal reflection, it went there. And this way, my dear, it suffered multiple total internal reflection inside the fiber. Am I clear? That is in core area, because this is core, na? I said this is core, and outer this one, the covering to the core is cladding. Because earlier in my real view diagram of optical fiber, you observe. So here this area where the light is traveling, right, is the core area, and the covering here, this double line I have drawn, is a cladding which surrounding the core. So my dear, let's start with this topic, that how the light is transmitted from one end to the other end with the help of the fiber. Right, and this is one of the very important question also. So let's start with the first point, my dear. A light ray, you can see incident at one end of fiber. A light ray incident at one end of the fiber, at one end of fiber is passed inside is passed inside, you can see, am I clear, is passed inside and suffered multiple in total internal reflection. So nice. What I did, there's nothing more concepts about it, my dear. Simple. The incident ray, a light ray incident at one end of the fiber, you can see, is passed inside and suffer multiple total internal reflection. And why it suffered multiple total internal reflection? Why it suffered? Because, my dear, every time the angle of incidence is greater than the critical angle of fiber. Here, which material? Critical angle of what? Critical angle of fiber material. Right? Because here it is fiber material. No doubt that is made up of quartz, glass or silica. So here it is a critical angle because this is a core. Na? So here it is a critical angle of what? Of glass, of quartz or silica. But we say critical angle of fiber. So the incident angle which is made here, that incident angle everywhere at this point, at this point, at this point, at this point, everywhere the incident angle is greater than the critical angle of fiber, and hence every time it suffers total internal reflection, because that is the condition for TIR, that incident angle should be greater than the critical angle. So my dear, that's what I am asking. A light ray incident at one end of the fiber is passed inside and suffer multiple total internal reflection because the angle of incidence, the angle of incidence is greater than the critical angle of fiber material, you can say. So why it suffer the multiple internal reflection? Because the angle of incidence is greater than the critical angle of fiber material. So it suffers multiple internal reflection. Am I clear? And the point number 2, there is no loss of intensity. There is no loss of intensity during the propagation. There is no loss of intensity during the propagation of light signal from one end to the other end. There is no loss of intensity during the propagation of light signal from one end to the other end. I hope, I'm sure you understood. Thus, the optical signal is transferred from one end to the other end of fiber. That's all. I hope. How does the light propagate through optical fiber is clear. So how does the light propagate through optical fiber? Very simple, sir. When a light ray is incident on one end of the fiber, you can say, is passed inside. It is this light ray is incident at one end of the fiber. This is one end. Is passed inside and suffer multiple total internal reflection. Not one total internal reflection. 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiple total internal reflection. And why it suffer multiple total internal reflection? Because the angle of incidence every time यहाँ पे एंगल ऑफ इंसिडेंस है, यहाँ पे एंगल ऑफ इंसिडेंस होगा, फिर यहाँ एंगल ऑफ इंसिडेंस, हियर एंगल ऑफ इंसिडेंस. Every time the angle of incidence is greater than the critical angle of the fiber material. Am I clear? And second very important point, sir, there is no loss of intensity during this propagation of light signal from one end to the other end, and this way, my dear, the optical signal is transferred from one end to the other end without any loss of intensity. I hope it is clear, my dear. So this is all about your how does the light propagate through optical fiber. Now we will discuss what is light pipe. What is light pipe and what are the applications of the optical fiber. Let's start for what is light pipe. Now my dear, about the light pipe, when I talk about what is a light pipe, before going to the light pipe, I just wanted to tell you one very important information with the fiber. My dear, I have drawn the fiber in front of you right now, how the light is transmitting through the fiber. My dear, what the science has observed, even say the fiber is bent like this. Say the fiber is bent, right? I have bent the fiber. You can see fiber is bent. So if I bend the fiber also, my dear, if I bend the fiber also, then also the intensity of the light does not have the problem. The intensity of incident beam and the intensity of the outcoming beam is remains same even the fiber is bent. That is very important point I am saying. So this is to be note, my dear. Even a fiber is bent, even a fiber is bent, the intensity of incident beam and outcoming beam the intensity of incident beam and outcoming beam remains same. That is, there is no loss of intensity. Why I am saying, my dear? Because sometimes the fiber is very long. And suppose I have to put in my stomach. Suppose I have to put the fiber through my mouth into my stomach. तो बेंट होना चाहिए. बेंट नहीं होगा तो फिर वो फाइबर मुंह से स्टमक में कैसे जाए? Try to understand. And the process is called endoscopy. I am going for application of optical fiber. This process is called endoscopy in optical instrument devices used for medical purposes. इसलिए my dear, this is the important concept I should tell you that even I bent the fiber. बच्चे अपने को फाइबर अगर मुंह में डाल के उसको ऑप्टिकल फाइबर से मेरे स्टमक में एवरीवेयर का इमेज निकालना है, डिफरेंट ऑर्गन्स का इमेज निकालना है, इंटेस्टाइन का इमेज निकालना है. सो दिस फाइबर हैज a kind of a property of bending, and even if it is bent, sir, intensity of the signal, optical signal entering and outcoming beam should not be different. There should not be any loss of intensity. Sir, bend होने से intensity loss हो गया, bend मत करो, ऐसा कुछ नहीं होता. So my dear, this is very important to say you all that even a fiber is bent, the intensity of incident beam and outcoming beam remains same. Am I clear? So band, when I say band, so band is nothing but we say it is in a form of pipe. Okay. But now the question is, what is light pipe? What is light pipe? Now my dear, if I take a bundle of fiber like this is one fiber I have drawn. Now let I am drawing the second fiber. Let I am drawing the third fiber. Let I draw the fourth fiber. I'm trying to show that I bent the fiber. So here I got, here this is called bundles of fiber. This is bundle of fibers. I hope it is clear, my dear. It is bundle of fibers, and this bundle of fiber make light pipe. The bundle of fiber, the group of fiber, when I take a bundle of optical fibers, my dear, then it is called a light pipe. So what is a light pipe? A bundle of optical fiber. A bundle of optical fibers are called light pipe. So first I have make you to note this, my dear, that I can bend the fiber. Am I clear? So when I bend the fiber, even a fiber is bent, right? Bent means I have tried my level best to make it pipe. Pipe-like shape. But light pipe is different. A light pipe is bundle of fibers is bent. So even a fiber is bent like pipe-like shape, like pipe shape. The intensity of incident beam and outcoming beam remains same. And what is light pipe, my dear? A bundle of fiber, bundle of optical fiber is called a light pipe, are called light pipe. Now, my dear, here one point, one question. Why it is not work with one fiber only? Why I have took the bundles of fiber? Why I have taken number of many fibers? And it make a light pipe. But why we did it? Why not one single fiber is to be used? What is the reason why the science required a bundle of fiber and constitute a light pipe? That is important to think, because, my dear, a single fiber, because a single fiber cannot form the complete image. Beautiful. A single fiber cannot form a complete image. You know what the science has talked about this? Science told that let us divide the image. You broke the image. You break the image into number of dots. Am I clear? You break the images in fine dots. And each dot will be observed by each fiber. So one fiber will take the image of one dot. So all fiber together, the bundle of fibers will form the complete image of that object. If the object for which I have to suppose to see the image is broken into a number of fine dots. So here I am writing that because a single fiber cannot form the complete image. So to get complete image, complete image, what I should do? I should break the image into a number of fine. So to get the complete image, my dear, what should I do? I will, to get complete image, let the image is broken into fine dots, and then each portion of image is, so what I did, let the image is broken into fine dots. एक image I have broken into fine small dots. See, then each portion of image, my dear, each portion of this dots, because I have broken the image into a number of dots. So each portion of the image will be observed by a separate fibers. Each portion of the image will be seen through a separate fiber. And this way the complete image can be seen, my dear. So this is such a nice topic, my dear, that each image is supposed to be broken into fine dots, and then each portion of the image is seen through a separate fiber. That is a separate. This is a wonderful concept. I hope you are getting. This is why the reason that, my dear, we have the sciences constitutes a light pipe. Because अगर एक फाइबर रहेगा तो शायद इमेज पूरा ना आवे, बट अगर इफ इट इज अ बंडल ऑफ फाइबर तो क्या होगा? I have broke the image first into a number of fine dots. Suppose I have to see the A, so I broke the A into a number of dots like this. And then each dot, that is each portion of the image, is observed by a separate fiber. And thus the complete image can be obtained without any loss of intensity. This is a light pipe, my dear. This is the concept of light pipe. Please take care. So first I told you that, my dear, I can bend the fiber. I can bend the fiber in form of pipe, in shape of pipe. Because pipes are used to bend. अपने घर में वाटर पाइप हम बेंड करके रख देते हैं घर में, मोड़ के. थोड़ी लंबा पाइप ऐसे ही रखते हैं. इट बेंडिंग, पाइप सब नेचर है बेंड होना. So similarly, I can bend the fiber also like pipe shape. Or like pipe. Don't say shape, like pipe. So like pipe, I also can bend the fiber. But why the science thought about to bend the fiber? See, I am doing the important concept. Please listen to the things carefully. Why the science thought to bend the fiber? Because they wanted to make a light pipe. They wanted to give the name. They are coming across the word light pipe. And therefore they first taught the concept that fiber can be bent like pipe. And even, my dear, even you are bending the pipe, even I am bending the fiber, my dear, there is no loss of intensity. That is important to think. That is, incident beam and the outcoming beam has the same intensity, no loss. So science is tried to make a light pipe. पहले bend करके pipe लाया structure, फिर बोला आप light pipe बनाते हैं. But what is a light pipe? Light pipe is not one single fiber, my dear. Light pipe is a bundle of fiber. It is a bundle of fibers. Am I clear? And why the science thought about bundle of fibers? Because one single fiber, Professor, cannot form a complete image. And therefore science thought, let us first to get the complete image, let us first divide the image. The image is broken into a fine dots. And then the science assigned, एक dot को एक fiber observe करेगा. Let us break the image in fine dots such that each portion of the image, I said each portion of the image is observed by a separate fibers. I hope, my dear, and thus the complete image can be obtained, can be seen and thus the complete image can be seen without any loss of intensity. So this is the concept of light pipe, my dear. So now let's go on the applications. So about applications, I will go for applications fast now. The last 5 minutes to do the applications. So my dear, I hope you all understood with the topic of optical fiber from my side. What is optical fiber? On which principle do they work? How the light is propagated through optical fiber? What is the concept of the light pipe? Why the science has decided to make the light pipe to get a complete image? It is not a single fiber because it is assigned a work. One fiber will see one image, one portion of the image. One fiber will see one portion of the image. So if there are number of fiber, in this way the entire image can be get through, can be observed, can be seen without any loss of intensity, my dear. So this is all about. Let's begin with the applications of the optical fiber henceforth now. So now, my dear, let's start with the applications of the optical fiber. That is the last part under optical fiber. What is the application? So here I am writing applications. The first very important application is a light pipe. Right now I have taught about light pipe, and this is the reason why we are teaching you the light pipe. So you should know where we are using this light pipe, where you are using this bundle of fibers. Am I clear? So this a light pipe, my dear, a light pipe of optical fiber. Yeah, a light pipe optical fiber is used for optical and medical examination. Is used for optical and medical examination. और लाइट पाइप ऑप्टिकल फाइबर, जो लाइट पाइप का ऑप्टिकल फाइबर है, जो लाइट पाइप टाइप ऑप्टिकल फाइबर है, मतलब जो बंडल ऑफ ऑप्टिकल फाइबर्स होते हैं, दे आर यूज फॉर ऑप्टिकल एंड मेडिकल एग्जामिनेशन. And this technique, medical examination, when it is used, the technique is called endoscopy. In medical examination, this technique is called endoscopy. And what is this endoscopy, my dear? I will tell you. A light pipe in this, a light pipe is inserted into the stomach. Am I clear? In this, a light pipe, endoscopy technique क्या है? I am explaining that. So a light pipe is inserted into the stomach through mouth. A light is transmitted with the help of a light signal, you can say. A light signal is transmitted with the help of light pipe. Simple. क्या किया मैंने? A light pipe is inserted into the stomach through a mouth. पहले stomach में entered किया through mouth, इसलिए bend करना पड़ता है. Through mouth, and a light signal is transmitted with the help of light pipe. Am I clear? Scattered. Transmitted with the help of light pipe is scattered. This light signal which is transmitted with the help of light pipe is scattered by the stomach, by the various part of stomach. So a light signal is transmitted with the help of light pipe first, which is scattered. by the various part of stomach and produce a final image without any loss of intensity. This is a process of endoscopy, my dear. So this is what you are supposed to know, that a light pipe is inserted into the stomach through the mouth, and then a light signal is transmitted with the help of the light pipe. Am I clear? And that light signal is scattered by the various parts of stomach and produce a final image without any loss of intensity. Am I clear? And that final image which will be obtained, it will be definitely will tell the person suffer with what kind of disease. So the final image is produced by the light pipe, my dear, which is transmitting the light signal into the various part of the stomach, which is scattered in the various part of the stomach, and there is without any loss of intensity we get the final image. So this is the process of endoscopy. So my dear, I have written a light fiber, a light pipe, optical fiber is used for optical and medical examinations. Am I clear? In medical examination, this technique is called endoscopy, and here I have explained you what is endoscopy. Here in this talk, I explained you what is endoscopy. What is endoscopy? A light pipe is inserted into the stomach through the mouth, and then a light signal is transmitted with the help of this light pipe, which is scattered by the various parts of the stomach, and the final image is produced, my dear. Am I clear? Without any loss of intensity. The technique is called endoscopy. Now the second is, my dear, it is used in transmitting, as I already dictated when I started my video, it is used in transmitting and receiving. It is used in transmitting and receiving the electrical signal. It is used in transmitting and receiving the electrical signal, my dear. But my dear, you must be thinking, sir, it is optics fiber. It is the optical word. I understood optical signal is transferred. How you said the electrical signal is transferred? Because the name is optical fiber. It is used to transfer optic signal. Na? But you are saying it is used to transmit and receiving the electrical signal. ये क्या समझ रहा है? That is in telecommunication. Here I am writing telecommunication. That is in telecommunication, my dear. So ये कैसे हुआ सर? इलेक्ट्रिकल सिग्नल कैसे ट्रांसमिट करेगा, माय डियर? ये तो नाम तो ऑप्टिकल था, नाम तो ऑप्टिकल फाइबर है, ट्रांसमिट तो ऑप्टिकल सिग्नल करना चाहिए. सर आप बोलते हो इट यूज्ड इन ट्रांसमिटिंग एंड रिसीविंग इलेक्ट्रिकल सिग्नल. ये क्या है? एंड that is it is in a telecommunication. That is used for telecommunication, my dear. So how it is? So my dear, here there is one statement. Please make a note of this. First, electrical signal is converted into optical or light signal by using, there is one word, transducer. Please, I will teach you this all when we'll go for one chapter. Earlier there was a communication in our 12th standard where we are using this word transducer. My dear, transducer, it will be used for conversion. So here I have used the transducer first to convert electrical signal into light signal. And now when it becomes light signal, now I can use the optical fiber to transmit. So ultimately the electrical signal is indirectly, you can say indirectly transferred from one end to the another end. So, and therefore science told this part. First you convert the electrical signal into optical. Electrical signal is converted into optical or light signal. This is important to think. Otherwise, after 2-3 months, you'll think about it. Oh, optical fiber, how about electric relation? So, my dear, you should know this. That optical signal is get formed. The light signal get formed from the electrical signal by using transducer. And once I obtain the optical signal, now I can transfer this through the optical fiber. So you can say here with this language that electrical signal is indirectly transferred with the help of optical fiber, because first that electrical signal is converted into optical signal by using transducer, and now it will be transferred, and this process is used in telecommunication, my dear. And believe me, my dear, this is also a statement that near about 2000 telephonic talks, 2000 telephonic conversation, please make a note of this, I am not writing, nearly 2000 telephonic conversations can be easily, without any loss of intensity, can be transferred by a fiber, by a single fiber. Just imagine, by a single fiber, I am not saying bundle of fiber, by a single fiber, at least 2000 telephonic conversation can be transferred from one end to the other end without any loss of intensity. So this is the method. First, electrical signal should convert into light signal by using transducer, and then it will be transferred. Okay. And third, my dear, it is used to transmit optical signal, no doubt. It is used to transmit optical signal, and this is in you can see 2-dimension picture. So it is used to transmit the optical signal, that is in 2-dimension pictures, you can see. So my dear, this is no doubt it is used to transmit optical signals. Optical matlab light signals, and we are using that method, we are using that techniques and forming 2-dimensional pictures. So I hope you are getting this third point also. Fourth point is, my dear, it is used in photosensors. It is used in photosensors. Now, my dear, what is photosensors? You must be knowing. Photometric sensors, they are photosensors, we can say, or we can call this as photometric sensors. And these photometric sensors measure rate of flow of blood, my dear. Fifth, it is used in refractometers. It is used in refractometers. What is refractometers? It measures refractive index of liquid. Oh God, such a nice applications you are observing, that it is used in a light pipe, my dear. A light pipe optical fiber is used for optical and medical examinations. In medical examination, these techniques are called endoscopy. I explained this, what is endoscopy, that in this a light pipe is inserted into the stomach through the mouth, and light signal is transmitted with the help of light pipe, which is scattered. Here you can say, which is scattered by the various part of stomach and produce the final image without any loss of intensity. Am I clear? That is the method called endoscopy. It is used in transmitting and receiving the electrical signals. That is in telecommunications. Now my dear, here the doubt is that how electrical signal, it is optical fiber for optical signals. But how it is for electrical signals? So first, electrical signal is converted into optical signal by using transducer. Third, my dear, it is used to transmit the optical signal, I already written, and the 2-dimension pictures, you can say. right? It is used to transmit optical signal and two dimensions picture, you can say, that is in two dimensions pictures. And my dear, it is used in photosensors or photometric sensors. And what is this photometric sensors? It measures the rate of flow of blood. It measures the rate of flow of blood. And the last, my dear, it is used in refractometers, where it measures the refractive index of liquid. So at least two applications you should aware about for optical fiber with the exam pointer. But if you know all 5 applications, this is much better, because sometime now a board asks refractometers used by which purpose, or refractometer work on which principle. Am I clear? So this is, of course, it works on optical fiber. So everything which I have written is work on optical fiber, my dear. So they are the applications of optical fiber. And optical fiber is the application of total internal reflection. Your optical fiber is based on the principle of TIR. I hope it is clear, my dear. So that's all from my side. I have completed entirely with the optical fiber. Thank you very much, and Jai Hind you all. Study hard. Study these 2 topics very well for the applications under TIR. One is, my dear, total reflecting prism, and the second is, my dear, optical fiber. So that's all from my side. Thank you very much, and Jai Hind you all.